Can you hear me?
Yes, Daniel, I can hear you.
We start now, or we should wait a bit?
I think we can start.
Okay. All right. Let's check. I think we have roughly people here. We have about 40 participants. Okay. Good morning, everybody. Thank you for joining us again this morning. This is just a quick um Q&A section about the Capstone project. First and foremost, I want to thank you for staying long in this training, online training. It's not the best one because there's no physical interaction. It's time bound, so it's not like a physical space where you can interact with students. But we've tried as much as possible to create forums and you know weekly presentation and interaction section. Um, For many of you, I believe this is your first experience, and it's not also easy going through learning something new, most especially programming language through an online section. But if you are able to make it from the first week to the last week, I would say congratulations for persevering, for being patient. It's not usually an easy journey. Takes a lot of efforts to be able to go through something like this. So we thank you and congratulate yourself. Even if whatever thing you aim to achieve, you've not been able to get through all of them, but I believe that with time you'll be able to um, learn and understand better. So many people have been asking questions since week 2 about how to go about the capstone project, and we try as much as possible to respond to them every week. But today is just to go through the description that was provided with the link. I shared this link now in the chat, and just for those who are interested to go through it and see what's there. So the question is, why are we doing a capstone project? Um, the usual thing when you are taking just a regular course or subject is to write an assignment or write a quiz or maybe write an exam and then any score that justifies that you've mastered or learned the course, the topic. But when it comes to programming language, um, because it is hands-on in the sense that you need to practice. So it is only learned by practicing. It is not learned by reading. It is not learned by listening. The best way you can learn programming language is by getting your hands dirty. The same way you can only learn something like calculus by sitting down and not just listening, but also writing, learning how to solve the mathematics through the proof and the rest of them. Um, so that is what motivated the whole capstone project. It has become one of the best ways of showing proof of work that you've learned something. And since last year, we have been doing this whereby participants are meant to submit a capstone project to be able to earn a certificate. So yeah, in order of priority, yes, I know there are exercises in your Jupyter notebooks or assignment as is in the learning management system that you have been using so far. But this is what you can demonstrate as, oh, I conceived this project and I did it myself. In the case of exercises, the instructor created the exercises for you. So the instructor made a decision of the problem. Same for the assignments. The curator made the decision or the instructor made a decision. But in the case of capstone project, you expected to, using the knowledge that you have so far, your interest, come up with an idea and use the skills that you've learned in the course of the training to demonstrate that you can solve problem, analytical problem. And that is what the capstone project is meant to achieve. So what I'm saying this is for those who may not have started, you need to take this seriously. This is your proof of work. This is your go-to that you can share to anyone in the future. to say, I did this project, I conceived this project, this is the motivation, this is why I'm doing it. To demonstrate a couple of things. Number one, that you understand the concept of problem solving. Number two, that yes, you are, might probably still be a student, maybe in your grad or starting your master's or even PhD, and you do not have programming experience, that you can take a problem, an analytical problem in astronomy, and then you can employ programming techniques to solve that problem. You can tell somebody tomorrow, oh, I know how to code in Python, but then that is just your word. But when you show them that this is what I did, they'll be able to look at it and say, oh, wow, this is beautiful because they can see the steps that you have taken. They'll be able to see your analytical skills, how you're able to move from step A down to anywhere you want to stop. So that is the whole idea behind the Capstone project, right? So we've also made it time bound because it's not something that should last forever. Time bound in the sense that there is a speculated deadline that you should submit your Capstone project. I think we still have 1 week from now or so, if I'm correct, labor.
Yes, you do. I think the last week is the 8th of July.
8th of July. So a week today. So I believe you have been working on your capstone project and that maybe you are confused somewhere. Maybe there's still some things that you need to iron out or you need clarification on. That is why we are meeting today. So for those who already started the project, I commend you. For those who have not started, please make sure that whatever thing you're going to learn today should be enough for you to quickly come up, finish your idea, and start working on the project so you can submit before the deadline, which is a week today. So, in summary, Capstone is about demonstrating capacity that this you have learned this course, you can use what you've learned so far to solve a problem. Many people have been asking questions, do I have to show all of the skills that I have? No, you cannot. You should not. In short, it is not you cannot do that for many reasons. Every problem does not mean cannot adopt all of the methodology that have been taught to you in this course. You cannot employ all of the method immediately in solving a problem, right? But there are things that you can do depending on the kind of analysis that you want to do, which is, oh, data, first and foremost, is the important thing everybody's looking out for you. We want to see that you can actually conceive an idea and relate that idea to a data that exists somewhere, get the data, do the regular data cleaning, do the regular data analysis, think about the kind of science that you want to do, think about the kind of result that you're expecting to get out of it, and use your programming skills to derive those analysis, right? So it could evolve so many ways. It could even be a simulation. It could even be a theoretical stuff. It could also be normal astronomy data sets, maybe exploring the data, trying to find outliers. It could be machine learning, it could be astronomy and just normal astronomy analysis. It could even be formulas. It could be even deriving certain relations and all that. It could even be showing distributions and explaining it. But the whole idea is that you need to make sure that you 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 have an idea of what you want to do and whatever thing you want to do can be presented because all of these things are about. But just moving forward, we've designed, so one of the rules is that you should do this in a Jupyter notebook, right? Um, in the whole course of this training, the material that have been sent to you or shared with you are structured in Jupyter notebooks. Now, Jupyter Notebook is very, very essential for many reasons. It's widely used because it provides a presentation template for you as a learner, not just for you as a learner, for anyone to quickly read through text, read through formulas, tables, equations, whatever, graphs, code in one user interface, unlike scripting. So it is also shareable in the sense that you don't need to do a lot of things. You can just open it in a browser and look through and read. Even if the person you're sharing it with do not understand a programming language, they can understand the text. They can be able to maybe looking through visualizations or formulas. They can quickly make sense of what you are talking about. That is why it has become the widely adopted way of sharing analytical codes, most especially for things like Python, R, and Julia, right? Okay, we've been talking about the need for you to have a topic, right? So what is a topic? A topic is nothing other than the problem that you have in mind, right? It's no other than a description of the problem, a short description of the problem that you want to solve, right? So supposedly I'm interested, say, oh, let me use a general thing that is probably not us. Let's say economics. What is the trend today? It could be there's a war currently going on, like the US-Iran war, and it is impacting the price of crude oil in the market. And I can say, oh my goodness, this is a problem. I want to analyze how the prices of crude have been fluctuating during this whole, is it 6 months or 5 months war. To say, I could come up with a topic like investigating the price of crude oil during the USA-Iran war or Russia-Ukraine war. In that case, anybody that hears the title, reads the title, sorry, will make sense of what. So your topic title should be descriptive, right? Yeah. Um, and then because again, you have this problem in your head, but when you're able to define it as a topic, it becomes easy. It's going to now make you understand that makes you understand where you need to head to. In this case, what do I need to do? I will start looking for economic data that provides information on prices of crude, maybe on a daily basis. Then after that, I'm going to think of, oh, how do I want to navigate this? Um, because the reason why I'm using this is something that you can easily investigate. Just want to use an example that outside of astronomy, just so many of you who are not yet grounded in astronomy can easily relate with, right? Because I might use one specific area in astronomy and some of you may not understand it. Yeah. So what do? You can start checking the market. So you can probably go to Google, where do I find crude oil data prices for every day or whatever? You can go check. It shows you that. You can see, oh, I'm checking for social duration during this war. How long has this war lasted? Oh, it probably started in February till now. What do? You see if you have the data from February to now. So in that case, maybe you go to Google and say, I'm looking for data that shows prices of crude oil. Google will tell you, oh, wow, there is a bunch of data. But you might go to the data and see that these prices have been there for more than 10 or 20 years. Do you need the whole data? The answer is no, right? That is where data cleaning and processing will start from. Remember, you would also have to describe the data, where you are getting this data from. Good. And then, so that's it. But just not to waste our time, I'm just going to use this notebook structure here to define this. So like I said before, your title and objective, which is something I've already described, your data set description, like in the case of this whole crude oil, I've described that, oh, I'm looking for this, I want to solve this problem. Now, where do I get my data from? Crude oil prices. Is it a time series data? Yes, it's a time series data. Next will now be, do I need all of this data? No, not really. You're not investigating price of crude oil forever. You're only looking at a duration, maybe 5 month duration, which is something you are going to describe in the text for people to know that this is where you're focusing, which is where you're focusing on. And then because you already have that information, you can begin to think, how do I sieve this data to only collect the part that I'm interested in? So this is where your programming analytical skills will come in, which will now be, how do I use Python to only select the duration of data that I'm interested in out of this very big data? Now, when you not have that, that is called data cleaning. That is called data cleaning, right? Data selection, actually. not necessarily data cleaning, data selection. Then the next thing you need to do is to also check the data to see if there's an error, because it's also important that you have to check. Like you might, if the data is listed every day, you can check something like the mean, the median, the max, right? Now, when you check those values, you need to also do some investigation to confirm that these values are within the range of what crude oil prices have sold in the last 5 months. Why are you doing that? Remember, these data sometimes are inputted by humans or might be produced by um, computers. There might actually be a time that, oh, there might be an error somewhere and nobody picks that up. So imagine you come and then you see something like max of crude oil is something like, say, $200 in one day. You don't just take it. What you need to do is to first and foremost check, was there ever a time throughout this year that the price of crude oil was $200? If you search online and you see such information, then it means that, oh, wow, the data is accurate. But if it's a case whereby you searched and you never saw such, then it means that there might actually be an error. That's why it's also important for you to investigate, right? Like you also have to use your thinking capability to just question the data by yourself to confirm that things are in order. These are the quality checks that you need to do. And these are some of the things that you do during data pre-processing, right? You investigate the data and see whether it is correct. The reason why you're doing this is so that you can trust the source of your data, right? If a couple of things are where it means that this might not be a right source, it might probably be that this source is corrupted or they are not providing accurate data, right? You can go probably look for somewhere else so you can collect the correct, accurate data. So it's important that people do this, because sometimes what has happened these days is that a lot of people always trust data. Maybe they see data somewhere, just trust it 100%. They don't investigate it. At the end of the day, you might only discover after spending your time doing analysis and then begin to think about your interpretation or results. And then it becomes a problematic to you that, oh, maybe for some reasons, something went wrong in the data collection and you body, because you did not do any investigation, you have wasted your whole time. So it is key that you do such investigations. Then, in that case, when you confirm that your data are in order, you can begin to think of the kind of analysis that you want to do, which is what we call it exploratory data analysis or just analysis, to be honest, all of them. So the whole area of exploratory data analysis and modeling analysis fall within the same purview, whereby you can think of, oh, okay, um, who am I presenting this data to? Even if you're not presenting this data to anybody, it is important that you think about how you can make your data analysis useful for an average person to understand, right? Imagine spending the whole time doing this work, and at the end of the day, you are the only one that can understand it. This becomes useless, right? What is the essence of doing it? Because you want to share it. So this is when you begin to think of, what kind of analysis do I do? So that an average person who may not have this background, can effectively understand what I'm trying to achieve. This is where things like statistical data analysis comes in, right? To begin to do the whole thing like a measure of central tendency, people that want to do maybe, um, mm, I've already mentioned it before, median. You can also say, oh, over the last 5 months, what is the average cost of crude oil? You can say that. What is the maximum price crude oil have sold in the market since February? Oh, you can say that. You can also say, what date did this price occur? What is the lowest the price have sold, right? These are the things that you can begin to think of, right? And many other things. You can also say, make a visualization like a time series showing the time of during this period and the prices of crude to say, okay, oh, given this time. So you see what I'm saying now relates so well with those who do time series in your time series section. time series analysis, right? Where you plot time against something like flux of an astronomical object. Um, yeah, flux of astronomy objects. It could be the magnitude. It could also be maybe spontaneous spectra, HRI. If you did, say you are doing spectroscopy and observing a star or a galaxy every day for, let's say, 2 months, you can plot things like the H alpha emission or the equivalent weight of the H alpha or the emission or absorption or whatever, depending on the kind of things that you're looking for, and see how they modulate over time. It's the same thing, that's time series data for you. Now, in all of this, the reason is for people to appreciate how the prices vary or how the property you're looking for, brightness varies to a star or a galaxy or any other astronomical object, exoplanet, or anything you can think of, AGNs, quasars, whatever. Right. Now, when you begin to see that, you can begin to think of, okay, do you want to model it? Some people do modeling where you can begin to think of, are there theoretical models, pre-existing theoretical models that can explain what has been done, right? That can explain the performance, the behavior of the distribution, right? And although I'm not a specialist here, but I remember Najam spent some time during I think, week 3 or so, statistical analysis discussing some of those examples, right? Where you begin to even think about, oh, some people do. I'm not very expert. I think this is also where you can see things like Monte Carlo simulation, hypothesis testing, and the rest. Thinking of maybe hypotheses or statistical methods that can quickly fit within your distribution, right? In some cases, if you are looking at some distributions, can begin to think of, oh, chi-square fit and the rest of them, right? Oh, does it follow a normal distribution? Is it Gaussian? And the rest of them, right? So these are the kind of things that you can think of. So you can, if it's a time series stuff, you can also think of what are the models like that can quickly fit in that case, or maybe try different models and see the ones that follows your distribution. This is where concept. This is like what you need to think about, or what kind of models can help me achieve this, right? Um, so I think that so I do think that it's important that we that you do all of this. I'm not sure the other thing I'm missing out here. Okay, another thing I could also like to talk about is maybe things around machine learning, because I know machine learning is something that has been trending for years now. For over a decade, machine learning has become a conversation that a lot of people want to talk about. It has become one of the widely adopted method for investigating data or doing data analysis because of what, yeah, especially for those who have large data, we want to do something like predictive analysis or do something like classification. And it's very, very useful in astronomy, right? Because for many years, decades, astronomers have been collecting data using different telescopes, space-based and ground space telescope. And then it means you have tons of data. Because you already have this data, you can think of how do I use this data to create a model that can now be used to perform predictive analysis. Predictive analysis not just necessarily because you're predicting the same data that you already have. No, because of course observations are still currently ongoing. Supposedly new observations coming tomorrow. Without having to do all of the nitty-gritty of manually doing some inspection, can you use this model to quickly make prediction out of this new data? So that's what the concept of machine learning is, right? So like learning from previous experience and using that to try and predict new information. A good number of times it works, some other times it doesn't work, but it's more like it helps you to get started quickly, right? So yeah, machine learning is very, very beautiful. With it, it has also evolved to the larger artificial intelligence now, where we now have things like large language models, computer vision models, many other models, even time series models, speech and the rest of them for doing predictions. But then that's it. I know we only touched machine learning a bit. I think we only had regression, a few, one or two regression problem and classification problem, which, of course, it's just to give you an intro. It is not for you to become an intermediate, but it's just for it to motivate you to see how you can. Maybe after learning at least a good level of Python, you can go try machine learning by yourself. Today, there are tons of courses, free courses online and on YouTube teaching machine learning, end-to-end machine learning, going deeper. There's Stanford University course on YouTube. There's MIT course on YouTube. There's Harvard course on YouTube. There's so many, I think Carnegie Mellon University, many of them you also have from other universities across the world, from Netherlands, they are there, both machine learning and deep learning, right? And they can go from theoretical aspect to hands-on aspect. So you can try that. You also go to places like Kaggle, go to places like Coursera, Udacity, I'm not sure if they still exist. Or yeah, or Udemy, you are going to see tons of courses, right? Yeah, many of them, they have plenty Jupyter notebooks. So you can even search on Google with GitHub, you see tons of Jupyter notebook exercises on machine learning, or even free books that you can find on machine learning and Git learning. So they are there, GitHub repos with codes and stuff. So nowadays that you also have era of LLM, AI applications, agents. You can also use AI to augment your learning, things like ChatGPT, Anthropic, Google Gemini could also help you break things down. Or some of you, Notebook LM, I think from Google is a very good resource for learning these things. Yeah. So the whole idea is do not get drowned in the whole information that have been given to you in this course. Think about the ones that are relevant for your problem and adopt them to solve your problem, right? And then when you do all of this analysis, maybe you did normal statistical analysis, you did normal visualization, distribution, and all of these things. Try out different kinds of distribution. Try and see if you can fit those distributions. Use things like SciPy, use things like stat model, right? So maybe I skipped a couple of things. So it's just giving you a clue. So whether you have your data, you downloaded this data somewhere. What would be the best? What format is it in? Is it in CSV? Is it in text? Is it HTML? Right? So these are the things that you can think of. So if it's HTML, it is CSV, it is TXT, it is that file. What are the existing Python frameworks that you can use to read them to a Jupyter notebook or in Python? Maybe you can go to your week 2 and look at the notebooks, example notebooks, or things like pandas were used. See things like NumPy. You see if NumPy can read the data for you. See if pandas can read the data for you. If it reads the data for you, right? Um, does the data make sense in the data frame? Like supposedly read it in pandas. Does the data make sense? Is it reading it properly? If it's not reading it properly, you can also consult Google or go to AI and maybe if you're encountering any error, it might also point you on maybe a few other frameworks that can be used to read the data accurately. If you are getting data through an API, they might also have their own way of getting it. A good example is majority of astronomy data, tabular data sits in Visia. Majority of astronomy data sits in Visia archive, right? Imagine you go to Visia to manually, you can go to Visia to manually download data. That's beautiful. And if you manually download the data, is it saved in CSV? Is it saved in Votable? Or is it saved in fit format? If it saves in CSV, oh, it might be easier for pandas to read for you. However, if it's saved in something like Votable or fit file, pandas cannot read that. I don't know, for recently, maybe I've not been following them, unless maybe they don't have a new framework to do that. I'm not sure they do that. But Astronomy have a Python framework for doing that, which is what? AstroPy. So why would you waste your time going to use pandas? Why not just use AstroPy? right, to read the data. Beautiful. Now imagine you don't even want to go through the stress of manually downloading the data from Vizia. What can you do? You can go to Vizia, do some investigations, and after the investigation, you can find a table information, and then you use Astro query to load the data. Just there's a Astro query documentation. You can use that to pass in the table header name, ID, and then it loads the data for you. Beautiful. You have it, you view it in data frame format, do the filtering that you want to do with it, collect the sample size of data that you need. If data is so big, this is just something I want you to understand, like some of you who are going to be dealing with it. Supposedly you find a data that is so that meets the kind of thing that problem that you want to solve. It might be so big. How do you handle it? That is when you begin to look at the limitations of your hardware. Supposedly you are running this on your PC. How big is this data? Is it in like 5 GB, 20 GB? In that case, it becomes a problem for you. It means you cannot process it on your machine. Because maybe some of you are using like low PC, low memory PCs, like say 8 GB RAM, 4 GB, or some are even using like 4 GB RAM, or maybe 16 or that 2 GB RAM, depending, right? So, but if you want to solve this problem, what can you do? You can also describe it in your data. You can also describe this information in your data description and then make justification that, oh, instead of loading all of this data, you're going to collect a sample of that data. That is still science because of what limitation of your hardware. I'm not sure. I don't know if anybody have encountered this, but I just kind of like may hint on it that these are some of things that you might encounter, right? This is why you see a lot of astronomy institutes usually use things like cluster, big data processing machines that uh, allows you to use big RAM, big memory size to download or analyze very huge data sets. The people in radio astronomy know what I'm talking about. Actually, when you're dealing with images, you can see, let's say, telescope data, say something like VLA data, observation, or meerkat can go as high as maybe tens of gigabytes, or in some cases, even terabytes. I've seen data that's like up to 2 TB after observation. Then this is not something that you can process on your PC, right? So people in India, like Ayuka, they have data clusters where they analyze their data. In short, every big astronomy institute usually have these things. But remember, you are a student, so you are probably not a researcher that have access to these resources, or unless you have access through your supervisor, especially for masters and PhD students. If that is the case, you can make use of those platforms, those resources to do this. But if you are not, you don't have such privilege, just restrict yourself to a sample of the data. Remember, what we want to see is your idea of problem solving, not how many size of data that you worked on. So I just wanted to throw that up. Right now, imagine you've done all of this analysis, depending on the kind of things that you want to solve. And one thing I can also recommend, although I don't want you to become AI powered, I don't want to. So one thing you can do is, especially for some of you that are early, like students that may not have done your own research before, you don't even have a research topic yet, maybe you're still an undergrad, is nowadays you can also brainstorm with AI, right? You can quickly get a clue. Supposedly you're looking for a mentor or someone to answer you, you're not getting any feedback from anyone. You can quickly give clue of the kind of problem that you have in mind and say, can you point me to this? Is this thing doable? What kind of analysis? Because sometimes you can think of analysis that you have in your head. You might list them. It might be like two or up to four. But then because you are not really grounded yet in research and your time is constrained, you don't have enough time to engage a lot of people to ask further questions, which is what you usually gain because of working with a supervisor that is already experiences that it can begin to give you more ideas on how you can see the problem. I think you can also explore AI to see if it can also provide additional analysis that you can do, right? Yeah, can tell you to say, um, given this data and given this problem, ensure you provide additional and accurate information of the data that you have. And we get to give you a guideline of all possible analysis that you can do with that data. In that case, you can see that the kind of analysis maybe you already had like 4 in mind, you can probably increase it to like 7 or 8. But remember, it is AI. AI can also hallucinate. It can also come up with false information. So when it brings up those things, it's also important for you to quickly go to Google and check and see, oh, this thing has mentioned, this is something that someone have done before. It is something that someone have done before. You can quickly just go through, check archive to say, okay, let's see what is on archive. Is it making sense? Does it relate with what you can do? Is it something that you can do within the limited time? Because some analysis can be like, oh, doing modeling, right? Your data might be small, but that may not require that you need to go and start downloading a couple of frameworks, a couple of modeling codes, which you don't have any experience in. So you see that you don't want to waste your time. So this is why you need to also do. So the same way you investigate your data, the same way you need to also investigate the responses that AI will generate to you. But what I'm saying is that it opens up your mind to see all possibilities, many of which you can use immediately. Some others you might probably not use, you might probably have in mind that you can do later at your own convenience. So that's by the way. Now imagine you've done all of this analysis. The next thing will be what? Results. Results. How many of these do you want to actually present to somebody? Hmm? It is important. You can do 1,001 analysis, but if you cannot present it, you first have to even understand it. Does this make sense? Is this relatable? Are you convinced? Right? Now, this is where you need to also do a bit of reading to understand that, okay, I have this results. Is this something that I can present? Is this something that I can interpret myself? Imagine you go and take time to this data, and then you plot all of those things. You see some where distribution, it can be the morphology. And is there a way for you to interpret it? And interpretation varies. Interpretation is a skill, right? Yeah. In I remember when I was talking about when we did presentation for time series data, we saw some light curve that shows bumps twice, right? So you can say, what is it called? This kind of thing, what is it called in astronomy? This is something that you need to also research on. Supposedly you have that kind of behavior. Oh, something like 2 bumps. What is going on? Okay, in astronomy, when you have a light curve go up and down like that, it's called flaring, right? But in what condition? Maybe it's also confirmed, you don't just assume, right? You check literature, quickly check online. These days you have access to internet, so you need to make it your ally. You don't just sit down, idle, and just be thinking. No, when you see a behavior, a pattern, quickly search and see if that pattern is something that someone have done before. And then in that case, you can see if read through and see how they interpreted it. Read the text, read the figure caption, and see where it is meant, the figure is mentioned, and see how it was interpreted. Is it close to yours? Then you can quickly get an idea of also how to interpret your own, right? Because AI may not, something like ChatGPT, unless you take the picture and put it there, might not be able to interpret it for you, right? Right. So that is it anyway. So think about it, how you present this thing, because it's important. Remember, don't assume that the person reading this is better than you. Do not assume that. No one is a bastion of knowledge. Um, there's something that you know better than your instructor. I want you to always assume that there's something that you know better than your instructor. There's something that you know better than your supervisor. So while you are making your result and interpretation, don't assume that the person reading it knows it better than you. No, that is not the case. In the course of this, lectures, you've seen people come up with questions. Even the few times I was present, I just tell you, oh, sorry, I'm not aware of this, right? Because yes, even in astronomy, there are so many areas in astronomy that people specialize in. So have that at the back of your mind, right? Yeah. So especially for like high level topics, there are places that the instructor might be very, very good at. There are places that your instructor might also not be very good at. So if you pick a topic, there's something that interests you in that topic, and that is why you are doing it. Don't assume that the person who is going to read your projects automatically understand. So set up your mind to teach the evaluator or to teach anybody who is going to read through your capstone projects. So you need to be as descriptive as possible in your own language. Don't use AI to write. If you write things in AI, it's very easy to dictate. Right, even if it's short, so even if it's like 100 words, beautiful, 50, beautiful, but make sure you condense and explain things in a way that people can understand. That is what we are looking for. Originality, right? Yeah. Connect all the things that you are doing from one, don't just jump places. Make sure there's a connection from the beginning, from title, description, data cleaning to result and interpretation. Right? So after you've done your that, you begin to in your conclusion. Make sure you conclude and connect everything that you did. And if it's possible, this is now a test for you. There are things that you could not achieve in that work. Future work will tell us how much investigation that you did. Like, are there things that could have been done that were not done for many reasons? In the case of an example of very big data, we took a sample of it and you did your analysis, right? So it is a part of a whole. Now, when you are done with your conclusion, you can also state in your future work, given the limitations that was experienced in the course of this project, right? That in the future work, you intend to analyze the whole data when you have the adequate resources that could be hardware. It might also be a case that you feel like if you start doing this analysis, you'll not be able to finish it in the next 1 week. You can also say, oh, the intent that. If you feel like the data is incomplete, you can also state it and say, oh, if you think this data, beautiful, we've done this analysis. Or some of those that feel like they want to do something like machine learning, you can say future work will be on. I don't know why I'm giving you all these ideas. Future work will be like maybe using things like machine learning to build predictive models so that future data, these models can now be used to predict future. You always make sure that there's something there for you, something that is left out that you can give the reader to motivate them to see that the problem has not ended, right? Like if it was in the case of let's say Russia, Ukraine, not Russia, Ukraine, US, Iran war, oil prices. If you are doing this now, so you are doing this step now, you can also say future work would be that over the last 5 months, you've done this analysis, but the future work is that if this conflict continues in the next 1 year or 6 months, you need to also check to see how this price of this commodity is performing in the market. Or it could be that even if the war ends, you can also do that to see whether there's going to be a significant difference in the price of crude before and after the war, right? In the case of astronomy, the same thing. You can take data from anywhere and maybe you can check this data I'm using now for this analysis is the data collected years ago by so instrument, by so telescope. Let's say something like TESS. If you're looking at a body of object, let's say a star, you're analyzing the light curve of a star. You can look at, okay, this data now, what's the data that's currently available? Which sector of test data is available? And then you can also say, given that test is still in operation, maybe in the next 1 year or the next 2 years, when they get new data for the source, you might want to do this analysis again to compare, maybe, are you seeing a particular distribution? Maybe is the period going to change? Or maybe in your analysis, you think like there are other kinds of analysis that you were not able to achieve because your data is limited, right? So these are some of the things that you need to think about. It could also be a case of what's the what's another example I can use now? Something like ZTF. ZTF is Wiki Transient Factory. It has been producing light curve data for different astronomy objects, mostly used for transients. It's more like the transient discovery, most popular transient discovery telescope. Imagine you go and collect certain data with it. You could also say that in your future work, things like using data from LSST, very, very useful because now LSST just started operations, right? So maybe in the near future, they might have robust data for some class of object. If you're looking at a particular object, or in the case of you're looking at multiple objects, you might have enough data. You might want to now do this because a new data is in town. So you want to compare to see if your analysis agrees or whether they differ. It could also be a case of telescope change, like, okay, which I've already mentioned it here, in the case of radio data. You noticed before there were previous old telescopes like GMRT, VLA, old ones, but now new breakthrough instruments are now happening. We have Meerkat, ASCAP. You also have the VLA new generation, VLA NG, NG VLA, right? You can also say, oh, we looked at maybe things like first data, a couple of other ones, Canada, whatever, galactic plane, some of these things. And now a new data is coming. Maybe there's already a proposal currently ongoing, or there's already a new survey that's currently ongoing. They'll say, maybe if we have this data, you need to also mention the source of the data that you're expecting to use for the analysis or instruments. You say, if we're able to, if in the near future, this is currently ongoing, in the near future, if the data is available, maybe it will help us to provide additional information. You need to also give hints on the kind of information, right? So these are the kind of things that you need to think of in your conclusion and future work. And please provide us with references where you're collecting your data from. It is important because you've gotten these ideas from somewhere. You are not a magician. You did not just close your eyes and everything came to your head. All of the knowledge that you have gathered, ideas came from somewhere. So it's important that you acknowledge them by providing the references. You understand? Like at least a few papers. If you got this data from somewhere, their data must have provided a reference. How you need to reference them, right? So if you go to Visia now to collect data, automatically you see a reference there. Make sure you add it. If you did any kind of analysis, that analysis, make sure you trace where the analysis is coming from. You've heard something like Lum's-Cargo periodogram. Fourier analysis, right? For a few. These things are not much. These things were people's ideas. So we need to make sure. Oh, so if you're talking about Lum's Cargo, do you reference one or two people? Check literature and see how they do the references. Add those references, right? So it is important that that you um, that you do things. Any method that you used, if you used any fitting, did any form of fitting from SciPy, go check. There's always a reference to it. Add those references. It's important that you learn this habit because otherwise, what you're simply doing is just plagiarism. Now, because of time, I think we can quickly go through. I've already mentioned a couple of places where your data sources are coming from. Gave you hints, but do not limit yourself to this. I believe many of you know some of these things better than I do, depending on the kind of problem they want to solve. EXA Gaia archive was used in the course of this training. NASA exoplanet archive is there. These links are clickable. I just want to see. So this is the ESA Gaia archive. I believe you can query data anonymously. You don't need to create an account, but just know that anything that you're doing is time bound. They have, you can Google about how to do this yourself. You can come to maybe the best thing to do will always be to use advanced ADQL query. Let me see. Let me see. I think they do have query examples here. So you can see query examples. Just know that this is just you using Gaia data, right? Um, I think it allows you to query data from other sources. I'm not sure, but it's not what I want to do. If you just want to, maybe some of you are already familiar with this. If you want to do this, I'm not saying I'm recommending it. I'm also just giving it to you as an option. But then you have NASA exoplanet archive. For those who are interested in working in exoplanets, I think they also do have advanced search. Here, I haven't used this before because I don't work on exoplanets. Maybe you want to have a particular object in mind. You can put the name of the object, search, and download the data. Read the documentation. I understand how to do this, right? Yeah, or you can also see if they have, I think it's showing the documentation here. They do also have things like JWST, test, Kepler, K2 data. I think they also have a couple of tools. So you just need to read. Sorry, I'm hearing some noise. I don't know what is that. You, Martin, your yeah, good. Okay, so just go through it. These things will be there for them. You have Astro Query. Astro Query is because remember you are doing these things in Python, so I would actually recommend that you see if it's possible for you to even query the data in Python, that would be beautiful, right? Astro Query is here. There were a couple of examples in the workshop that got you through how to query data with Astro Query. Yeah, right. From different, but from Visia, they support many catalogs and stuff or something like that. They support many catalogs, archives, and the rest of them. So you see available services depending on the kind of thing you're interested in, which is I always recommend this one because it's quite easy if you know what you're doing to get the kind of data that you're looking for. All right. Then Visia itself is beautiful because this is where you can search. They do have up to 27,681 data available. These are publications from different people. Even Gaia data is sitting here. If you want to find Gaia data, you can always type Gaia. You will see it shows you all of this. You can find different candidate letters. The Gaia DR3 data is this one. Is it again 355? Yeah, this one. And then they also have different sections. This is the original data release. This is the astrophysical parameters, supplementary parameter, many other things. If you're looking for spectra, this is for spectra. I think they also have for photometry. Sure. Yeah, EP phots, that's the photometry light curves. So there are plenty of data here, right? Although you need to be a bit need to be a bit, do I put it? I'm not sure. You can only search by, I think allows you to search by name. Is it the expand search? So yeah, you can also search by wavelength, you can search by emission, you can also search by topics. Yeah. And then it's going to show you data related to that topic. So this could also be a very good start for you. And let's say things like brown dwarf. So you see here, you need to pay attention to this. It says there are 116 matching catalogs. If you do find catalogs, then you begin to see informations about the catalog. It gives you then the title of the catalog. And these are mostly table. These are tabular data, not like mostly table. These are tabular data, and you can begin to think of okay, the numbers beside it are like the number of rows. These numbers you're seeing here are like the number of rows for that data. You see in this case, said infrared photometry of late type brown dwarf. Supposedly this is you are interested in this kind of topic, late type brown dwarfs that have photometry. You can quickly click here and but then you see it still contains tons of data inside. This I think this is a particular target. Yeah, so let's say I click. I don't know what this is. I'm not going to tell you like I know. Let me see which one has the highest number here. Flaws calibrated. So you see, this is just this is a wavelength data. This is the spectra, right? Is this what you want to work on? Depends on you. I don't know what the object is. Oh my goodness. Why did it show me that? No stable catalog or table. Why? Just click submit. Okay, yeah. So you can see this is the data. It's basically just two columns, lambda and flux. So this is a spectrum. You can take this. If you want to take this data, you just need to take this and go to Astro Query and run it yourself, and it pulls the data for you. You can now do any kind of analysis that you want to do, but make sure you understand what the data you want to use is. Is it relevant for the kind of work that you want to do, right? Yeah, this says a full sky 20 parsec census of stars and brown dwarfs. Imagine you're looking for brown dwarfs are like very in the we call it again the HR diagram. The brown dwarfs are like the lowest of the lowest classes, very low mass, very low mass stars, right? Let's see what this looks like. Oh, this also has a bunch of tables, so you still have to go deeper to pick out information. Just want to see if there's anyone that will be very interesting. So searching for data can also be tricky in a way. But these are the things that you need to do for yourself. And if you know what you want to, here I say planetary mass. So usually is this one, table one, proper motion, Iraq observations, and all that. Let's say we'll go for table one. It shows you information on the Gaia information, Euclid information, Iraq information. So this is more like the infrared and optical properties of a sample of brown dwarfs, right? So it all depends on what you want to work on, right? So just so you know, and let's say I go to things like, let's see there AGN. AGN has about 1,509 matches. If I come here and search, it's going to show you different kind of information. For people that want, I think this is an information on Redshift survey. It shows the 2DF. I'm not sure what 2DF stands for again. QSO is quasi-stellar object. These are like, these are more like the I think it's the orientation of AGN where you're looking at it. It looks like a point source, right? They look like it looks like looks like a star because you're looking directly at the center. So I may be wrong, but then this provides information on the redshift, right? So you can go through it, read the columns, and know what the columns stand for. Not every column of the data will be relevant for you. This is what you need to know. You just need to figure out the ones that are relevant for you and see how it's going to help you in your analysis. Imagine I submit this, although, so I can see there's the redshift information. So you can probably just say in this case, I'm looking at analyzing the redshift information of that region of the sky, north and south galactic poles from, let's call it 2QZ, whatever, and 6QZ with another blah, blah, blah. It's up to you. And then you do that. You have information. Like in this case, if this is the redshift, you can quickly start plotting the redshift and looking at the distribution. What does the redshift tell you? Are there anomalies? Are there things that you think are very nearby? Are there things that are farther away? You just need to understand what the concept of redshift is. I think this is kind of similar data that was used in the machine learning class. I'm not sure. It is not this data anyway. You can also need to like show the distribution of that region. Like, oh, this is actually the region of it in the sky. Because remember, visualization is very, very important. You can say you are doing this. Nobody knows where it is. But since you have coordinates, you might also want to plot the coordinates in the usual coordinate plotting form for people to know, okay, this is actually the part of sky that you are referring to. These things have been classified. You can also, do things like, is it what you guys call it again? The bar chart or so to show that the number of classes, like distribution of the classes. There's a star, there's a QSO, there's any LG. I'm not sure what it stands for. They also have things like star DA. Don't know if it's like a star D. Is it like a white dwarf? I know there's DA white dwarf. There's DZ. But this information, you definitely will read it from the paper. You see, there's a paper connected to this table. The best thing will usually be click here, opens for you, and immediately opens for you. You read through. This is where you get information about the data itself. Don't go blindly and start using data. Quickly read through the abstract. If you are impressed, then you go to the paper itself. Here, for some of you, if you are not within an institution, some of the publication might not be accessible to you. You just need to go to the preprint. In this case, I will go to the preprint to open the archive. The archive is free, so you don't have to worry about accessing it. So you can quickly read through and see what the paper is talking about. That is where you might even get an idea of the kind of analysis that they did. Then maybe you can see if you can replicate the analysis or you have other analysis in mind that you want to do. So this data is very rich for any kind of stuff. You can use it for machine learning. You can use it for anything that you have in mind because this is similar to what machine learning. You can simply do basic classification, regression. You even have multiple classes here, and the data it's not that bad. It's about 49,000 yeah, 49,000 sources rows. It's fairly used. It's something that you can do with a Rickety PC, right? So that is it. I think I've covered a lot of the things that I need to do. Then this is the grading rubric. So we also listed other data sets. This was last year. So a lot of people were not in astronomy. So I want them to say if you are constrained by maybe not being able to do this in astronomy, you can go find, even in Kaggle, you can find a few astronomy data sets in Kaggle and all that. So, but I do advise that to try and do something on astronomy. Grading rubric. Every information is now thrown to you, how you be graded. So for each of these things that you did, this is how you graded each of them. These are the grading points, right? Just so you know. And the description here is giving you a guide for you to know, okay, this is how all of these things I'm doing will be graded, right? And you need to score a certain points for you to earn a certificate. Try as much as possible to reach 70. This whatever you're doing is not going to be so deep. You might even use a very small data, but want to see how you can do your research, end-to-end research, get something interesting. Remember, just make sure you meet the criteria and submit a Jupyter, what's it called again? A Google Colab. A good way to get started is Okay, before I do that, I don't need to even get started. I can just show you if is an example. I'm not sure if you guys can see my screen. So we had a similar thing last year. So this is something that a couple of people came up with. So those who submitted, we had hundreds of capstone projects, right? Hundreds of them. Just so you know, you are not the first person to do this. So this example, can't remember who the author is, but this is an example of what they did. They came up with a title, objective, their data description, you know, even they said key features selected. You can see how the person was going down to describing the code, the features of the data that they want to work with, data cleaning and pre-processing. Even showed how they queried the data. So you see, this person did not download data manually. It just pointed you to a link and then shows you how to query the data. You can see a subset of the data. You can see it has the information he was talking about. I'm not sure what this thing stands for. I think the author listed all of this, right? It listed all of this. So, and then from there, selected the features they're interested in, did some analysis so that you can see. I didn't even talk about missing values. It did show that it dropped and said they were able to drop raw data sets. So this raw data set was about almost 6,000. And then they had to drop missing values because some of the data were incomplete. These are the kind of things that you need to do in the exploratory data analysis. Check if the data is complete. If it's not, are there columns or rows that are missing? You see, dropped about say 3922. Okay, 392. I'm not sure what changed here. So almost 40% of the data was dropped, right? Because here it was usually 59 something, and it is now 39. You see? But that data was still good enough. And then here, this person did machine learning analysis. And because you can see it's machine learning they did a bit of standard scaling. And did some exploratory data analysis to look at each of the features. You can basically see that how the distribution is. And this is where it did a bit of distribution. You could see each of the parameters. Try and be intuitive in your colors, just so that you don't make like, in this case, we could not see anything. I'm not sure what happened, but then, or it might also be that, okay, I'm not sure he did any sort of limits, but I don't know what happened. But then here, you could see how the distribution looks like. You can see this one. I think 1, 2, 3 stands out, and there's something here, right? And then they went further into all of other things that they did, other kinds of analysis that they did. This person knows what he or she is doing, was trying to focus to see if they can get results, right? And then make some visualizations and a couple of descriptions. So I believe this person is working on exoplanets. I'm not an expert in exoplanets. I barely know anything around exoplanets, but I know that if I take my time, like 30 minutes to read this, I'll be able to get a sense of scientific work. I could see there was, I think, um, yeah, a data reduction analysis that was performed, a dimensionality reduction that was done here. I think with that, they were able to also do a bit of anomaly. I'm not sure if it's anomaly detection or something. But then anybody can read this. I may not understand the code. Let's say I don't know Python programming. I may not understand the code, but everything is here from beginning to end. What it means is that even though I may not understand this, I can start this notebook, run it, and I get the same results, right? And then I can follow and read and be just like what was done for you in the Jupyter Notebook examples that were given to you. A quick question some of you might ask is, how do you do this? You can, if you have a Gmail account, you can open Google Colab for free. You can just type Colab here. Let's do this together. Let's come here. Go say Colab. Then it will say, welcome to Colab. And then you can create a new notebook. If you create a new notebook, um, yeah, that's it. Come here, give it a title. I can call this, maybe I can say books, Capstone. Enter, you text the name. Because the essence is that you can always come back to it. Supposedly you get busy, you can also leave it and come back to it and continue later. Here it's a text. I can think I should be able to convert this to, let me see. Okay, is it UCM or so? It's not working for this one. Yeah, so you can also move I can say text, right? Text, and did I move this up? Let me check. Then you can also just delete this cell. You can delete it. So text, you can probably just say title or hash. So remember this is a markdown. The text itself is a markdown. So there's a way to format using hash or many other things to do. It's something you can Google around, right? You can say bricks, capstone. I'm just saying, I don't know what your listing is, bricks, astronomy, capstone, that, blah, blah, blah. But this is not what you should not use this as your title. You see how it looks now, it is bolded. Then you can start writing something, oh, bricks, astronomy, see how it looks. So these are the things that you need to do. Then you see, create another cell. This is where you can write code. This automatically recognizes Python. So now they've even integrated Gemini chat. So Gemini, Google AI itself has been integrated. You can also use it to guide you, to give you ideas on what you can do. It also helps when you have a problem in terms of running an example, it throws an error. But sometimes it can fail. But if it fails, Google Gemini sometimes can be terrible in troubleshooting a code. Then you can just go to Google and search and see if you can find better answers. So I'm just saying, right? Usually you want to write your code, things like import, numpy, as np, blah, 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 imports. We done these ones, you don't need to install them. They're already imported, they're already there. You can see it even support, it's even suggesting for me. Enter, it runs. I can also create a text. Let's say I'm done with import. I can probably just say under section data, um, data description, depending on what you want to do. And then you can start writing, oh, your source, describe your source of data, blah, blah, blah. Then the next code. So you see, even if I close this, it automatically saves, but in worst case scenario, you can do Control S, or you can come to File and click Save. It's automatically save. So whenever you come back later, you open it and then you continue. This is for those who still haven't done this, but I believe by now you should know because a lot of your notebooks in the GitHub are connected to Collabs. You can open them. So now imagine you've done all of this just like these people did. Now this is another example of a capstone project last year. This person did something on MDWRFs using for test photometric data. You see the same thing, describe their title, aim, and source, and data source description, they reported. You see, they even had to go, they install their own, Python package. Not like, because I think while Google Colab contains a lot of packages already pre-installed for machine learning and data science, some astronomy Python package might not be there. So it's important that you can also use the same method, pip install, to install them. And then you continue. See the description, you see the imports, you see the analysis. This is them trying to query the data. Some of these things was done in time series analysis section, discuss. And then these are all the processes that they did. right? You can see the table data and all that until they got to doing this. Although there's a yeah, see all the light curve data. The person tried doing fitting. I think they tried doing some fitting. That's why you can see that. You can see beautiful. Try now different plots and all that, right? Oh, okay. It's actually so many. Yeah. Then here, result and interpretation. But then I think you need to do better than this. I'm just showing you, just so, I think there's another one. The name show, yeah. Predicting supernova conformation type from host galaxy properties. Stated objective, import, loading data, data description. You can see these are very, very beautiful. So you understand that you read your data, you understand the columns, data cleaning and all that, and advanced preprocessing. Yeah, see, this is a very shifting for distribution of log M, distribution of I think is a star forming ratio. Also, yeah, so you can see this. This is also very, very intuitive. This is beautiful. Right. Yeah. See, modeling and analysis. This is even going as far as doing machine learning and all that. Mm. So you can see there were a couple of steps that were taken. This is beautiful. I don't know if this is probably this person's project, but this is beautiful. Result and interpretation. You can see that this is now relating to like a paper. You see that the method that we described is also the same way you present in most publications. Now imagine you take all of this, you keep advancing on it. Now, what this thing method helps you do is that supposedly you're still, let's say you're an undergrad student, you start doing your project. You already know an idea of, okay, how to write these things in Python, how to collect your data, how to keep working on a Jupyter notebook until you almost done with your results. You can also be writing your text. Now, when you finish all of this, you can, if your plots are so beautiful, you can save them, download them, go to Overleaf or go to Microsoft Word where you are doing your writings. You can also take the text that you have written here, especially if you think you beautiful analysis. You can take them and put there, and then you have a working publication, right? Okay, beautiful. See what I'm talking about, conclusion and future work. So this try to follow the guidelines and then references and data sources. Oh, such a generous person. Even he or she went as far as referencing Briggs data analytics workshop because that is where the lectures, you understand, the lectures are very, very important, very, very ideal in helping them achieve this, doing this. And then the packages that they used, they had to also put the link. Beautiful, right? So I think I will stop here. I already passed over 1 hour. So please, if you have any question, the floor is open. Let me check the chat and see if there are questions. Okay. Okay, so um, okay, I see some of the questions are already there. I mean, have been answered. Okay, yeah, I'm only seeing this now. Of course, the samples have been shown. Fortunately, is it that my sound wasn't coming out clearly before?
Now you're okay, you're okay. I think they just had to increase their volume. You okay?
Oh, okay, okay, that's fine. That's all right. So, okay, the possible to say sample of. We've already done that. We've gone past that now. Yes, please use Google Colab. So when you are submitting in the LMS, you just need to copy the link of your Google Colab. Just make sure it is not private, right? For example, in this case now, you should see here, if I do share, I'm not sure they make it. So if it's a case whereby owner, general access, make sure anyone with the link can see it. Yeah, that's what you need to do. Make sure you set it to say, so if you come to share, um, automatically when you click this link, it will generate a link that you can share. Or just make sure you click here. Anyone with the link can view. Just put it in view. You don't need to comment. They don't need to edit. Viewer is enough because we just need to view. Copy the link and paste there. Yeah, so I think that works. So please, more questions. If you have any question, go ahead because I'm not seeing fresh questions. I think the things mentioned there in the chat have been addressed. Somebody is saying, can you please share some of the previous projects? No, we are not going to share it with you. Unfortunately, this is other people's work. Quickly just went through just so you get an idea of what you need to do. Think about your idea. The concepts have been given to you. Yeah, do your own research. That is why it is a research. The clue there is what we want you to do. So what you can do is probably go back to the video later in that section, read through, and because I know probably the project section was not so, maybe you spend at most 10 minutes. Yeah, but we're not sharing the project with you. These are people's work. And I don't know if it's you're still working on it or so. Yeah, because last year there was no project to share with them, right? There was no project to share with them, but this is just because some of you have been asking questions, right? All right, other questions? You can also Google, see, you can also Google projects like Capstone projects. Just Google, you can see examples. And make sure you tailor it to the way we have described for you, right? You will see examples from other courses, examples from maybe, yeah, other courses that is not astronomy, could be data science, could be machine learning. Yeah, just so you have an idea of how a capstone project should look like. Is anybody raising their hand or is it, I'm not seeing any chat now.
There's one.
Hmm?
Harrison? Harrison, go ahead.
Well, hello, good morning from Nigeria. Yeah, I just want to use this medium to thank Daniel, Mole, Professor Renado, Professor Najam Hassan, and Priya, Alexi, Mariana for this workshop, giving us the opportunity to learn data analysis in astronomy. That's been a lot, I would say. I also want to thank my colleagues, in every part of the world for joining. So I just a real quick, like I you talked about that we just had a little glance on machine learning. So, but if it's possible for us, I think there are people who want to use machine learning in the analysis. So I don't know. Are you, because when you were trying to say like we just had a little knowledge on machine learning, but it doesn't mean that we cannot use machine learning for analysis, right? I don't know
No,
if you
so
get me.
so here's the thing. If you can use, if you then some of the informations in the machine learning is enough for you to do. Like last year, people used machine learning. I'm just saying that if you know machine learning is relevant for your case, use machine learning, right? So because when you talk about machine learning, you have to think about the problem. So when you talk about a capstone, you have to think about the problem that you want to solve. If you think your problem is something that you can use machine learning to do, then go ahead and use machine learning. Because the essence of this is to show that you can solve problems. There's a topic that machine learning might not be relevant. If you are looking at, let's say, data set of one star, you want to analyze the light score of a star, of one star, you are not going to be using machine learning. It's a time series problem. So it means you need to focus more on the time series section of this course, right? Don't know if you get me. But if you're probably looking at a sample, like a problem, a predictive problem, like in the last case of redshift for maybe a region of the sky or a particular kind of object, or maybe classification of different kind of objects based on their information, metric, spectroscopic, or whatever. And you know there's data that exists. Well, of course, you can go ahead and do machine learning, right? But the point is, some people, because from the questions we have been receiving, some people think that, oh, you have to take one question and you have to use all of the method that have been described in the course to solve that problem. At the same time, we're saying no, do not do that, right? Just make sure you find relevant aspects of the course that can be used to solve a problem that you're interested in. So if you have a problem that machine learning can solve and you can find the data, of course, go ahead, beautiful, do it. I want to see it, right? So long as you know what you're doing, you can interpret what you have done. Yeah, that is the essence of it. Nobody is saying you should not. I also want to make it clear that this is a beginner course. So machine learning is very, very big. In short, in the future, we're planning to split this course into multiple sections for the year, whereby maybe basic astronomy could be what you can do for this whole period, and then the next section is something like machine learning. Machine learning is very, very big, right? Because we did not go in that. We did not even look at that. There are time series for machine learning. There's a different class called serious different sets of problems for machine learning astronomy. There's aspect of anomaly, which is even something that's very common in astronomy, which can be used to find things like transients and other phenomena in astronomy. You have deep learning aspect of it too that is very, very big. Like astronomy also collect tons of images, spectra. These things can be analyzing light curves, all that in astronomy. So it's very, very big, right? So it's just for you to know what you want to do and focus on it. Yeah.
Yeah, thank you. Can I ask one more question? Sorry, I don't know
Yeah,
if
go ahead.
yeah, I don't know. Maybe you have an idea, or Molly has an idea. Like, I received a mail yesterday regarding the hackathon program that will be coming up by October. So I don't know, is there um, any special preference that will be given to British students for the program? Let's say if you are to register for the program, I don't know. This is just like I'm trying to get an expo. Like, is there any maybe selection process, maybe to bring students to be able to have an edge for the selection process? I don't know.
Oh, well, so that's a good question. For many who do not know, you have the Breaks Data Astronomy Working Group Hackathon coming up in October, as part of one of the events in the big Breaks Astronomy Working Group meeting in India. The hackathon is centered around machine learning astronomy. And I think there are two classes or so, two problems that is open to solve. So of course, we believe that all the participants in this course are coming from BRICS countries. So one of the criteria is that it must be a BRICS member country, I think, if I'm correct. And then it's open for any one of you to apply. But again, there are questions there. I think hopefully the organizers too um, probably will have the criteria that they have for students that want to participate. So what you need to do is to make sure that in that questions, I need to really read more about it actually, that you meet the criteria, right? So focus on it. Of course, this is already an edge for you. I believe this is already an edge for you. Because I think we're definitely looking for people to have data analysis, data science experience, machine learning experience, but you need to do more, right? So if you're just starting in Python, I think you need to probably show more workings. In short, your capstone project should be very, very essential for you, which is why it's something that I don't know, maybe in the motivation or whatever. I don't know if they're asking for I don't know if they're asking for maybe project you have done before. If done, then if you probably do not have any project, maybe this is why you need to even spend more time after this because if you're going to finish submission next week, you can even spend more time on your capstone project. Maybe if there are things that you need to do that you know you did not do within the window of the submission for your capstone project, you can even spend more time on it, demonstrate that you can maybe solve problems in machine learning, read more. Do not limit yourself to, because why I said the thing about machines that do not limit you short for any of the topics that were given to you in this course. It's just an intro. Do not limit yourself to say, oh, because I did this week course, automatically I'm a master. No, consult other resources, read books, watch tutorials online, try out different examples that you can see, and so that you'll be able to get the needed, because I believe the organizers have the kind of experience they're looking for to be admitted. So make sure that you provide relevant answers and the questions that will encourage or motivate the people who will evaluate the submissions to do that. So that's the only thing I'm going to tell you, right? But this is already like an edge, but yeah, it all depends on how much effort that you put in.
Yeah, thank you. I actually, just like you said, there is a link for us to send a Google Colab link to a project we've done before. Yeah, I also need one clarification. You're talking about the submission of Capstone project. You said next week. Mole just replied somebody in the chat that is 28th of next month. So I don't know.
Let me
Yeah.
check. No, he said label.
I didn't hear his
Are,
question at the last point. He's
so
asking about.
are we extending the deadline to 28?
No. So the deadline, I think the document, I think in this document that you just went through, I think it says that we're giving them 2 to 3 weeks to finish the program, right? To finish the project, right? So the third week from the submission date is actually the 28th of July, right? So it's not an
Okay,
extension, it's just a period for you to finish within these 3 weeks that we're giving you, right? I think this is
okay.
more than reasonable time to finish the project, right? I think we're being a bit merciful with this, right? So we understand that you
Yeah,
probably.
there's no, yeah, beautiful. So there's no problem. So because I know this week, this year was actually extended because we had other topics. So again, you are getting a grace of additional 3 weeks. So please make good use of it. You have enough time to now work because it's flexible. 28th of July. Today is first, right? So that's actually
Yes, sir.
4 weeks in the making. Yeah, that's actually 4 weeks. So a grace of 4 weeks. I believe some people have been working on their projects. If you think your project is already very solid, you can submit. If you think you already achieved them, you can submit. Because we said that throughout the course of the program, you should start working on your capstone project, right? Yeah, but again, maybe because you want to spend more time to do something interesting, you can try out different things and do your capstone project. Now, coming back to your question, Harrison, again, let's say, for example, let's even say that the deadline is next week. That you submitted a capstone project next week does not mean you cannot continue working on that project by yourself. Are you getting me? If I am you and I'm applying for this kind of opportunity, I'm going to be grateful that, oh, I already have this course that I'm taking where I'm doing a capstone project. But if I want to really qualify, the capstone project is for you to earn a certificate in this course, not for you to go to Bricks Hackathon, because it's not like there was an original plan for both of them, right? Because last year there was no Bricks Hackathon, right? Now, unfortunately for you this year, there's a Bricks Hackathon. What are you going to do? Continue working on that project and keep improving it, even if you've gone past the deadline. You can even structure it into a project, a full GitHub project, where you can now have multiple examples, markdown write-ups, different sections. The same way you see we have folders here, it could now be for maybe different aspect of the analysis that you want to do and different scripts. With plots showing figures, section, writings. Why are you doing that? This will become a resource for you to share as the knowledge that you have gained. Sorry, Kieran, I'm coming to you. For example, if you're undergrad and you're finishing your undergrad, you want to apply for masters, you submit an application. One of the things that researchers want to see is that a student they want to employ, they want to recruit, has the programming experience. And how will you show that? Through this. Or you're a master's student, just finishing your master's, maybe you did all this course project master's, right? Or you want to do a PhD. You can also show this. So this is the idea, not that after this, you end it here. It's just something that will show as proof of work. Because most times in applications, a lot of times, hundreds of people will apply for one opportunity or two opportunity. So how will you stand out? You have to stand out by showing that, oh, you have an edge. I don't just know the physics or the assembly part, I also know the problem solving, research, science part, programming part of it. And with this, you share it, the person might just go through it, immediately they read through, oh, wow, this is interesting. It doesn't matter whether it is in that topic that they want to employ you or not, but they want to see that you already have possess some skills that is relevant for the kind of job that you want to do or research that you want to do. So that is the essence of it. And I don't want any of you to forget it. Now, another thing that you can do is after doing this capstone, write something about it and share it on your social media. Majority, I believe many of you have LinkedIn. Share it there on LinkedIn. When people see it, they will know, oh, you went through this course, you did this by yourself. Whether people looking at it are in astronomy or not, it gives them motivation that they know your research trajectory. So that's the essence of it. Yeah, Kiran, go ahead.
Thank you. Can you hear me now?
Yes.
No, regarding your voice, I mean, sometimes it is something like breaking your voice, maybe due to your position of the mic, maybe. Okay, I have two general questions, both you and Molebo. And we have completed quizzes, right? Now we are going to do capstone. Is there any weightage like credits for these things, quiz and project? And is there any chance of the project title will be highlighted on our certificate along with
I'm
the
not getting
credits?
you. I'm not getting your last section. I'm not getting you.
I mean, is there any scope for we are computing project title, right, for capstone. So is there any scope that our project title will be highlighted on our certificate along with the credits?
You need to score at least 70%, I think, so to be able to get a certificate. Right? So think about it. And if you can see my screen, this is the rubrics. This is how every section of the notebook you're going to, your collab notebook you're going to submit the site is going to be graded. So the maximum you can get for each section is listed here. So the maximum you can get for each section is listed here. Just so you know. Right.
No,
It's
that
important.
is not about the. I'm asking, is there any scope? Will they highlight our project title on our certificates? Because you are going to give on final certificate, right? So can we
I'm not
expect
sure.
our
I'm not sure we highlight your project title. I'm not sure.
okay
So
regarding
last year
that
we didn't
because
highlight. Last year we didn't highlight project title. No, we didn't highlight project title. But again, for you to earn a certificate, you need to score your capstone. You need to score. You need to reach the threshold to earn a certificate.
yeah.
So if you don't get up to that, you're not going to earn a certificate. Yes.
Yeah, we need to complete 70%. Yeah. I completed quizzes. Now this is one only. I completed some extent of this capstone also. So recently I'm applying this XI models, shape, those things. I'm doing that right now. So mostly by 15th or 20, I can submit that one.
Yeah, it's fine. Just know this deadline now been extended. It's not that you have to wait until then. If you finish your capstone already, For those who are following the instructions since week 2, and it's ready, you can submit. For those who are still working on it, please do your due diligence. I believe some people who are confused, maybe this is your first time. The information shared today is enough for you to get started, to know that this is what you need to do to stand a chance. Yeah, so any other question?
No, thank you.
Yeah, I'm talking about let me check the chat to see. Okay, nothing in the chat now. Yeah. I'm not sure this was said earlier. I said, could you combine its previous qualitative work you made if this capstone one is quantitative based? Because I thought the interdisciplinary approach for the scoring was only for the I'm not sure what you mean here. This approach, rubric approach, is for everything. So remember, any of these things, it needs to come with a text. Okay? So everything here should be descriptive. You did your problem definition is basically just descriptive. Data selection and justification is both quantitative and descriptive. Data cleaning. If you did any data cleaning, you need to explain what the data cleaning is all about. I mean, so you need to put all of that together. So the reviewer will read through your text and your codes, your visualizations, and your analysis for scoring in any of this. So it's not like, oh, because when you hear explanatory data analysis, you're just doing statistics and that's it. No. You need to explain the statistics that you did. The same way if you go to a paper, right? I think I did mention an example of a paper here initially, which is, I think it's this one. So here, although, so you can see a couple of descriptions. You can see the figures, right? There's a data description, there's a data section. You don't have to go write long text, but you should be able to explain what you have done. Because that is the only way that we can tell what you do. Right, so that's how you're graded. I'm not sure. I don't know if I answered the question now, or if you still have any clarification, you can raise up here. You can also unmute yourself. And any other question? Qualitative work you're doing right now is by making a near Earth Sonova book for a popular audience. If you think you have to show some analysis, remember, this is we have an objective here. This is you showing that you are doing stuff. If you've already made something like that, you can also add a link there, but that is not the basis of the work, because the reason why we are using the notebook is that the reviewer will be able to have access in one place where we can see what you have done. The idea of even that is even why we did not motivate people uploading notebooks, because you don't even want to go to the extent of uploading a book and manually opening it on your PC. It's going to be time consuming. We do not have a lot of resources in terms of people who go through this. Well, now we don't know. Last year we got hundreds of submissions, right? So this also takes time to read through these things and grade them, right? So make sure the information you made the required information we are putting in the for this course. If there's another thing there, the reviewer might just open it and look at it, but I'm not sure it's going to be graded for this course. To be honest with you, I'm not sure it's going to be. It can also serve as part of your reference, or this is something that you can sell to your community. But within the context of this course, we are more interested in your presentation in the journal. I want a constraint analysis for M87. Not sure why I'm not saying this fully. And Sagittarius in gravitational lensing. Nobody cares. We're not so concerned about any topic that you want to do. It is left for you to do it. Sagittarius, M87, they have tons of data sitting. You can find the data, you know the kind of analysis that you want to do with it. Go ahead and do it. Just make sure that you follow the template and description. Show us the codes and how you're coding your data and the kind of analysis that you're doing. Explain everything. Yeah, that's good to go. The whole idea of waiting for somebody to approve, the whole idea of waiting for somebody to approve your topic, I don't think it is nice because we're not going to tell you this topic is nice, do it, or this topic is nice, don't do it. But you need to focus on the grading rubric, the science objective, and make sure it is very clear. And that is why I said before, don't expect that the reviewer is an expert. The reviewer already have a template for grading you. So they are going to read through your work, make sure you are descriptive enough, make sure your analysis is very, very clear for them to understand. Then they will grade you. So the reviewer, in the course of reading your project, will learn something new. In the course of reviewing your project, will learn a new topic that they didn't even know exists before. Right? So that's what I want all of you to have in mind. Yeah, any other question?
Okay. Can you hear me, please?
Yes.
Okay, thank you so much, Daniel. My name is Solomon, and your session was quite has been so inspiring. Thank you, and encouraging at the same time. My challenge now is due to conflicting work demands. I have not been able to cover up the assignment for some weeks. Okay, but seeing that we have deadline for the capstone project, I want to focus on my capstone project, but I have backlog of assignment to cover up. Supposing I submit my capstone project and I've not covered up this assignment yet, what is going, how is that going to affect my being certified? Or
Okay, good.
can I go
So
back to the assignment after
yeah,
I'm done?
just to answer that because of time. So Solomon, at the beginning of this section, emphasize that you'll be graded with your capstone project. We know this is what happens in most online courses, that people a lot of times do not follow the trajectory, like meeting up with assignments and all that. But at the end of the day, we are looking at the most important thing, which is the value. So the capstone project is the value that you are going to create out of this course, and it supersedes the assignment. So at the end of the day, your assignment is just for you to learn and pick up on the topic. But have it in mind that for the fact that this course has ended does not mean that you cannot go back. Those resources are still there for you, right? You can still go and do this assignment, but focus on the capstone project, right? In short,
Thank you.
the reason why we designed the capstone project this way is that if you know the problem you have in mind, for many of you who are only just glancing through the notebook, this capstone project will now force you to go back to those sections and go and read more and figure out the code that you use to solve the problem. So focus on the capstone project, and that is, make sure you do it very well in such a way that your score will enable you to earn a certificate. That is what matters. Yeah. Any other question?
Thank you.
Well, if you have anybody in mind that you want to share it with, is it Indrendra? Sorry if I'm not pronouncing your name very well, Indrendra Sisodia or so. Yeah, of course, if you have a mentor, you can share that with. Just know that you're not supposed to share it within the group, right? You're not supposed to share it within the group. This is your personal work. The reason why we're saying this is so that people don't copy your work and all that. right? And everybody's work needs to be unique. Everyone's work needs to be unique, right? Because there's going to be plenty of submission. So, and we want to see your creativity here and originality. Do not burden yourself with thinking something that is very high level. Think about, find something that is quite simple that you can do that will help you gain all the needed parameters or qualities that are more like all the needed requirements for you to scale. Because some of you might want to go into something that you don't understand and you may not have anybody to put you through, or you may not have anybody to guide you. So start from what you know and go to the unknown. Don't go. It's not by, I want to go and do some high level topic. That's because think about it this way, something that you can easily find in data, something that you know the data exists. So if you have anything in mind and the data does not exist, forget it. Think of something else. Yeah, any other question? Okay.
All right. Thank you very much.
Yeah, Emmanuel.
Thank you for your talk and for your explanation so far. I appreciate it. I have two concerns. One is regarding the referencing. Is it proper to do in document referencing? I mean, inside of the notebook, just like in publications, can one do referencing inside of the notebook, or should all references appear at the end of the
At the
reference
end.
column?
At the end.
Okay. Then secondly is about the consulting rooms. What I normally come there, I thought that maybe that is a place where we get access to mentors and people who can guide us. I don't know, because I've been seeking somebody, access to a mentor regarding my Capstone project, which I've started. I've sourced data, I've filtered, but there are certain areas I would need guidance and assistance, but I don't know how to access a mentor. So these are my concerns. Thank you very much.
So here's the thing. We are constrained by resources, so you don't have a lot of people who are doing the whole mentorship and stuff this year. And what I would recommend is if you put out an open question, yeah, maybe some clarifications could be around code and idea in your conversation room. The student might answer that. But we've also designed this in such a way that whether with or without a mentor, you can go through this Capstone project. Sure, to be honest, the majority of Capstone projects do not require a mentor, right? But then, if your question is around maybe loading data, maybe what's it called? Yeah, loading data or errors, you can quickly put it in a general channel and then anybody can answer that. Those who have experience can answer that. You get me? Because I don't want a case whereby people will bring the constraint. The reason why I did not complete my Capstone project was because I didn't have a mentor. And this is one of the reasons why we're having this section today. Usually last year we didn't have this section we're having today. We only ended after the last course. Everybody had to go and submit their Capstone within 2 weeks. Right. Today we have tons of tools, assisted learning, like AI that you can use to guide you through some of the things that you want to do. Because if you have close to 200 people all seeking for mentors, the mentors will be constrained. Mentors will not be able to do their other activities for the day, right? And again, mentor might also not have an idea in the topic that you want to do. That's why I say any topic that you're choosing, make sure it's something that who want to spend your time on learn it and teach someone else, not looking for mentor to approve or validate what you're doing. Otherwise, it becomes like a student-teacher relationship, which is not what we want to achieve here. We want you to conceive your idea, get my point, conceive your idea, use all the resources that have been exposed to you in this course, and get it to something like this. Get it to something, those examples that you've seen. Are you getting me? Now, if you look at this is an example from last year. He provided references. The essence of the reference is not necessarily to you to format it the way you format in papers, but at least you need to point somewhere like this is where the ideas, the data, the tools, or the telescope for your work is coming from. You getting me? That is what we want to see. It's not so high level. So this is a very good example. He showed references for I think this person works on a correlation, whatever, supernova, water galaxy spectral analysis. The data was coming from SDSS. The part of the knowledge used in the course, used in the analysis, was coming from the BRICS Astronomy Idea Data Analysis Workshop. You can see it there, see I referenced it. And then the tools that it used, things like Astro Query, provided the link, Scikit-learn provided the link, Pandas. If you use other tools beyond this, you need to also do the same, right? Let's see for this person. See, this person just provided NASA Exoplanets Archive. Analysis conducted using Python libraries, Pandas, Matplotlib. I did isolation for REST PCA. Beautiful. Right, so there's no particular structure, but it's important that you follow the rubric. So if the reviewer is convinced, for example, if I'm reading through this, I'm reviewing this, I'll have to look at starting from the data description. You didn't mention the data sources. And how many packages did you use? Did you bother to even mention them? I think that is what this person did here. This analysis that you did you are not the first person to do this. Did you get the idea of somewhere? The data, where is it coming from? So you need to also score yourself while you are doing all of these things. Where you are each of this section, when you think you're done with it, review it. Supposedly you are the one grading this, someone else gives you. You already have the rubric. Normally in some other capstone, you don't see rubrics, but we try to show you the rubric so that you know how it will be graded. Right? Yeah. So this is a test of your intelligence, not like your own personal intelligence, and see how you can convince. That's why the capstone is not even shared to everyone. It is unique. And the reason why we make it like that is such that if it's something that you're still working on, you can continue working on it. You just shows us a little brief of it, because this might actually be somebody's project. So try to do this little part, and you're still working on it to finish their dissertation, right? You don't want to expose it to everyone, and it becomes an issue. Yeah. Okay, we are almost out of time. Let me see the chat. Okay, let me see. Could we stop one of this? Sure. Yes, we do have. You said other than the marks, we will get individual feedback on our results. Yeah, the reviewers can leave a feedback for you if maybe there's a room for feedback to get feedback from the projects, right? And again, I believe all of you are coming from an institution. You have your supervisors, you have people that you have as mentors. You can also share things you are working with them within your institution. I think that's also like very verifying, or anybody that you have as a mentor with you, wherever you are. I think that's also a good way. I believe that will also be a good way to encourage things, because while you are adding values like or using things like programming, there might be some scientific things that somebody within that area might give you that even a mentor will not give you. Right. See, Elizabeth said, this is what I tried in my question because we have score from quizzes, and if they give score for capstone, then they will specify such those weightage. No, everything will be graded with your certificate to be based on your capstone. Because capstone is the main thing. Capstone is what eventually is something that you can share to the public. It's something that you can present. Supposedly you are going for interview for your master's. In the course of your interview, you can, or in your application, you can put the link too and say, this is what I have done. That shows that you have programming experience. That shows that you have analytics experience. That even the lecturer or supervisor might not have a programming background, but they can read through to understand what you've done. Is it better to load data sets in our notebook using URLs, or is it better to download the data in our computer? Please, if you can, load the data directly in your notebook. Right? Load the data in your notebook. And these examples that you have seen so far, you can see if I want to run this, I can run it from beginning to end. I don't have to go manually download data sets. Right? But again, you can start working on your PC first, try out things, because I know you can encounter errors. Try out things when you're sure. You can also, if you don't know, you can also ask AI, how do I directly load this if you don't know? Because I know some of you only started programming recently. How can I just, maybe if you know this data is coming from a source, how can I load it directly into Notebook with Colab without having to download or upload them myself? Yeah. Yeah. So everything here is end to end. So I think we've touched on the number of the questions. The ones in the chat have been addressed. Is there any other question? Because we already like up. Time has been used up. If there's no other question, I think we can call it a day here. And then I will say good luck to all the participants. Please spend more time on your capstone projects. Be creative. Think like a researcher. Ask questions when necessary. Try out different tools available to you. Yeah. And then see what you can. Not sure we'll have an evening section because this is basically the same thing. Maybe not. Because I think we've captured all of the things that we need to, but we'll see if we have an evening section. Remember, the evening section is we'll not have an evening section. We'll just simply share the resources to everyone who came in the morning. Because evening section is supposed to like yeah. Although it's supposed to be like for those who are from different time zones or those who communicate in the morning. But I think a good number of things that needs to be said have been said. And if you can spend 1 hour on your projects, spend 1 hour on your projects, say for the next 3-4 days, I'm very sure you'll be able to have come up with something tangible. So make out time for your projects. This is not the best time to hop into meetings. This is more like spend time. All of these resources that you have, it's time for you to put them to work. Yeah, okay, guys. So I think Lebo, I'm not sure if we have anything. Do you think there's something we are missing that we've not addressed?
I think you covered everything. That should be all, I guess.
Okay. All right. So good luck with your capstone project. Be as inquisitive as you can, be as thoughtful as you can. And then in addition, for some of you, I think motivate yourself enough to see how you can make your capstone project stand out, right? You can search for capstones for different areas of research. You can see different examples, see how many of them that relates, be as creative as possible. That is what matters at the end of the day. Ensure that your capstone project is something that you can be proud of, is something that you can share within the wider community, something that will help you in your future research work, maybe even applying for scholarships or any other collaboration that you want to be part of. Yeah, thank you and good luck with it. And for some of you who are also going to participate or applying for the hackathon, please apply, but work hard enough on your capstone before applying so that you be, remember, it's going to be competitive. This is open to everybody. It's not open to only people here. So there are people who think that there are people who know how to program better than you. Many people already doing research. So it's going to be highly competitive. So just so you know that you need to put in more work, more research, more learning, and more, creativity for you to be able to get in. So thank you and do have a nice day.